Now, when they say this, what they want is they want the second derivative in terms of just x and y.
I know. Such a
Okay. So granted, that's how all of ours turned out a minute ago, but second derivatives are going to have the first derivative in them somewhere. Okay? So that first derivative you're going to have to replace with an expression for the first derivative of only x and y. So the final solution for this derivative should have only x's and y's and no dy dx's in them. Right? That's the way it should be. If you don't know what I'm saying, you'll see in a second. All right. So first one round, we're supposed to find the derivative, the second derivative with respect to x. So that means my operator is d dx. So apply d dx to both sides. Same thing we've been doing so far. E to 2y plus x, differentiate with respect to x on the left, and then this on the right. On the right is pretty straightforward. The right is just the derivative itself, dy dx, correct? Okay. Right, Cornejo? Oh. All right. So now d dx, that operator is going to apply to both this piece and this piece. So let's put the addition in between. So what is the derivative of x with respect to x? 1. 1. It's 1. So the more complicated thing is this one. So it's a chain rule.
So you have to do that.
So you have e derivative of e to 2y, and derivative of 2y would be 2. So
Carol, the derivative of 2y with respect to x
is derivative of 2d to the dx dy.
not dx dy, dy dx, right?
Yeah, do one.
Right. Times 2 dy dx. Okay. So in other words, what we're saying is this. It would be e to the 2y, that has to come back, right? That's the most outer function. Inner function stays inside, and you would take the inner function and differentiate it by d dx, right? But you know the derivative of y with respect to x is this symbol. So this thing's going to move past the 2 and apply itself to this, and just give you the 2 d by dx. It's a constant multiple rule, right? You guys see that or not?
Yeah.
I think.
Okay. It takes some getting used to. So now, what you could do, you could do one of two things. You could solve for dy dx right now if you want to, and then differentiate that with respect to x. Or you could just go ahead right now and just do another derivative on each side.
Another one.
You're gonna have you're gonna have to solve for dy dx anyway.
why not do it now?
Oh, let's do the steps.
Yeah.
Let's solve for dy dx now. You're gonna have to anyway. You need it for what I said here. Your final answer can only have x and y. It can't have dy dx in it.
So wait, before you do all
Yeah.
that, would it be better for us just to solve for dy dx as soon as possible?
I think so.
Okay.
I think so. That's what we do right now. Solve for dy dx. Okay, so we need to get the dy dx on the same side, so I should subtract this one over here, I guess, and subtract one. I guess it's faster to move this one over, right? Only one move. Just push this one over here.
What?
You want fries or onion rings with your burger, right? You don't really care, right? It's all the same greasy stuff going in your gut.
It's gonna be left on a hat if you take
Yeah, what
2 dy away from the side.
What are we doing?
Because you're multiplying
Does
to
it
2
matter,
dy
like-
dx. so
No, it doesn't.
you have-
Let's just put this over here, okay? That'd be okay?
Yeah.
All right.
Fine.
Put this piece, the underlying portion, on the right-hand side. So we'll have 1 equals dy dx minus e to the 2y times 2. I'm going to put a little 2 in front, right? Just look prettier. dy dx. Agreed? There's our equation. Factor dy dx to the right-hand side. So 1 equals dy dx times the leftover, 1 minus 2 e to the 2y. And now divide by that portion. So dy dx, written on the left now, just for, again, aesthetics, equals 1 over 1 minus 2 e to the 2y. All right. So we have our derivative that we don't quite want yet, but it's the intermediate step here. We have the first derivative,
Wait,
and it's written in terms of only y, it turns out. There's not even an x in it. Okay. So the y coordinate is completely determinative of the slope, turns out.
Be the opposite.
So now we need to take a second derivative.
Wait,
Okay? You guys okay with this?
1 second.
No?
Just give us like 5 seconds.
All I did was divide by this, pal, and I just switched the places so it looks like the standard way, derivative equal to stuff going left to reading left to right. That's all.
So why do we need to take a second derivative?
The problem told us to.
Okay.
Okay, wait, so say one more time how you got the negative 2e to the 2y to the 1 minus 2e to the...
How did I get this?
No, how you go from there to the next step?
Oh, I factored off the dy dx.
Oh, okay.
So you
okay.
take that out, and there's a 1 left, and like a placeholder there, right?
Okay,
1, and
yes.
then minus that.
Okay.
So now, take second derivative. So since we already have the first derivative solved for, that means we're going to apply d dx to both sides here. Okay? That makes sense? And now you see why this notation is what it is. There's 2 d's, so it's d squared, and there's 2 dx's, so it's dx squared, right? That's why the notation works out like that. That's why it's not dy with the 2 over here, right? The y is just the function, but the d happening twice, right? The derivative happening twice is going on the fact that this operator is happening twice. That's why it's written like that. All right, so the left-hand side is our symbols, right? D squared y dx squared. Say it that way, whatever. Equals. Okay, we need to take the derivative of this expression with respect to x. So what is the outermost thing happening with this expression?
Project.
What? With this expression?
Quotient.
Quotient, right? The quotient is the most outer thing. So this is a quotient rule, right? Quotient rule.
Why wouldn't it be the product you're multiplying the...
The 2 here.
Oh, no, I was talking about the d over dx, never mind, that's dy dx.
Oh, that's that's operating on it.
Yeah.
That's not. I should not make a dot there. That's just a ton. That's an action.
Okay.
The thing is applying. All right. So we need to take a quotient rule here. So bottom, 1 minus 2 e to the 2y times the derivative of the top. Well, that's easy. 0.
So that's how it would be 0.
Yeah, this is gone. That's right. But I just want to write it. So minus top times derivative of the bottom. Okay. So derivative of the bottom. Gonna be what? Derivative of the bottom. Derivative of the 1 is 0. Derivative of the negative 2 e to the 2y, if you look back, we computed e to the 2, we computed the derivative of e to the 2y already. If you look back, it was this, correct? So what's changed? Now there's a negative 2 on it. That's just a multiplicative constant. So therefore it should be negative 2 times this expression is what we need right here.
So negative 4.
Yeah. Negative 4 e to the 2y dy dx over bottom squared. You can go through the same logic again and realize that it's going to become this, but I'm just saying you've already done a lot of these problems where you do higher derivatives, especially implicitly, you end up doing the same thing again. Sine and cosines and e's especially. So Roger already told us this is going. That part's gone. So your negatives make a positive. So now